All right, I'll try to solve two problems in one video here. So this ball is kicked at 16 meters per second at a 52 degree angle. So I'll sketch that out. 16, and then I'm gonna have to get these components here. The angle's 52. So the horizontal component, that's the adjacent side of this triangle, will be 16 cosine 52 degrees, and the vertical component will be 16 sine 52 degrees, since it's the opposite side, and we have the hypotenuse. So let me go ahead and calculate those first. So for the horizontal side, just making sure my calculator's in degree mode here. Okay, 9.85. Kept an extra couple digits, 9.850. I'll just underline the two, though, that are significant. And then 16 sine 52, 12.61. All right, so those are the horizontal and vertical components of the velocity. So I'm going to do this projectile question by making headings. So vertical, horizontal, and I'll fill those values in that I just got. So vertical starting velocity v1 was 12.61 meters per second up, and horizontal v, which is constant, 9.85 meters per second. Okay. Reading the question, this ball strikes a wall that is 20 meters away. So the wall is 20 meters away. That is a horizontal value. That would be the displacement. 20 meters. And then vertically, since it's a projectile, I can record my acceleration due to gravity of negative 9.8 meters per second squared up. And the question is asking me, how high up the wall does the ball hit? So that's a vertical piece of information. That is the vertical displacement, how high. So I left a little bit of a space there because two values is not enough to get the missing value there for the uniform acceleration formulas. I need a third given value, which I don't have right now, but it's going to be time. I'm going to figure out the time using my horizontal information, and once I figure out the time, I can transfer it over to my vertical side and then solve my problem. So I'll do that. Horizontally, I'm going to calculate the time. Because this is constant velocity, we can say that velocity is displacement over time. And solve for the time. So that would be displacement over velocity. Fill in the values, 20 over 9.85. That's the 2 sig figs. So that is 2.03 seconds I'm getting here. to 2 sig figs. So that is what I'm going to fill in onto the vertical side. It's time is time. Whether you're talking about the horizontal or the vertical motion, the same amount of time passes. Now it looks like I have enough information to get the displacement. So the big 5 equations, it'll be the third one. And no isolating needed since I'm finding displacement. So I'll just go ahead and sub in the values. Okay, calculate that. Coming up with 5.4 meters here. So that's the answer to the first question there. And another thing you may be asked to do for projectile questions is to find the highest point that this ball reaches. This ball travels as a parabola. It hits this wall here. At some point, though, at some point in time, it got to some highest point. Maybe. Because I guess it is possible that the wall was over here a bit earlier. Here, we'll fix this. Find the highest point of the ball if there was no wall. That way we don't have to worry about it at all. So find the highest point of this parabola. Okay, so I was worried that it might have hit the wall before it actually reached the highest point. So I'm just gonna say there's no wall anymore and get the highest point. So I will, I'll just start a separate section here. So I'm looking vertically, and vertically, just going to copy some of these values down first. I'm not copying down the time though, because that time I calculated, that was for the time it hits the wall. Now there is no wall. Now this would be the time for the highest point, which I don't really know. But what I do know is that when it reaches its highest point, the vertical velocity will be 0 at the highest point. And that's the third value I'm going to use to allow me to calculate the displacement for the highest point, the vertical displacement for the highest point. So this will be a different of the big 5 formulas. It's going to be the last one. With V2 being 0, and then isolating for displacement. So that would be subtracting V1 squared on both sides, and then dividing by 2 and dividing by acceleration. Fill in the values. It's going to be the 2 sig figs. Because of 9.8 there. got a negative in the numerator, a negative in the denominator, so it's going to be a positive answer, which is good because we want this. This is the highest point. It should be a positive number here. So I'm getting 8.1 meters. So we could find out when this happens. And we could find out when this happens just by using a different kinematics formula and solving for time. I could go in and do this, and then I'll know for sure if it reached the highest point before or after hitting the wall, because I know it hits the wall at 2 seconds. So if I find out this time at the highest point, then I'll know that. Yeah, it's going to be less than 2 seconds, so I didn't even have to worry about that thing about worrying about it hitting the wall first. All right, so that's it.